Ignition sequence start.
Good morning, and welcome to this view of the International Space Station Flight Control Room at NASA's Johnson Space Center. These men and women are monitoring all the space station systems and assisting the Expedition 66 crew members as they move through their daily agenda of science, research, and station maintenance. While the American and German crew members have been busy with space station science activities this week, Commander Anton Shkaplerov and Flight Engineer Pyotr Dubrov have been getting set for a spacewalk next week when they'll begin to outfit the station's newest module.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire Mustachio. On the station, 2 Russian cosmonauts are gearing up for a spacewalk. On January 19th, Expedition 66 Commander Anton Shkaplerov and Flight Engineer Pyotr Dubrov of Roscosmos will exit the Poisk module around 7 a.m. Eastern Time for a 7-hour spacewalk. The duo will install handrails, rendezvous antennas, a television camera, and docking targets on the Pre-Shaw node, which docked to the Nauka Multipurpose Laboratory module in November. You can watch the spacewalk live on NASA TV, the agency's website, and the NASA app. New science on the station will study certain bacteria and fungi and their resistance to antibiotics. Researchers in the Microbial Tracking 3 experiment use environmental surface samples collected by astronauts aboard the space station to identify, analyze, and characterize pathogen dynamics and antibiotic resistance to predict which may pose a threat to crew health. Analyzing the potential risks to astronauts on long-duration missions also benefits life on Earth, as some of the same bacteria and fungi that have adapted to the spaceflight environment are the same as other environments, like hospitals, offices, and homes. This week, NASA's newest astronauts reported for training, while 1 veteran astronaut in space reached more milestones. On Earth, NASA's 10 astronaut candidates began training at Johnson Space Center in Houston, Texas. Over the next 2 years, the candidates will learn the Russian language, space station systems, spacewalking techniques in the Neutral Buoyancy Lab, and more. Upon graduation, they will be eligible for missions to the space station or the moon with the Artemis program.
Space to Ground.
In orbit, Mark Vande Hei is adding days to his long-duration, record-setting spaceflight. Vande Hei's mission to the station is scheduled to last 355 days, the longest single spaceflight for an American astronaut. He has already surpassed NASA astronaut Andrew Morgan's 272-day record and will eclipse former NASA astronaut Peggy Whitson's 289-day record on January 23rd. Follow Vande Hei's mission and the latest astronaut announcements on Facebook, Twitter, and Instagram at NASA Astronauts. That's all for today on Space to Ground. We'll see you next week.
As Leah mentioned, some potential future crew members on the International Space Station were the center of attention on the ground this week. NASA's new class of 10 astronaut candidates reported for duty at the Johnson Space Center and have begun their training. Take a look. These are the faces you'll be seeing from space and maybe from the Moon and Mars in the years to come.
Ladies and gentlemen, today we are introducing to you and to the world
My name is Luke Delaney. I'm a retired major from the Marine Corps, working at NASA Langley as a research pilot, and I'm now an astronaut candidate.
A NASA astronaut to me is an explorer at heart. I think they're the very embodiment of it. You get to inspire people from all walks of life.
4, 5, 2, 0, liftoff.
To me, it's somebody who's always challenging themselves and always trying to, push the bounds of mankind.
I wanted to be an astronaut since I was a little kid. I grew up wanting to learn how to fly, learn how to go to space. So some of my earliest memories are of wanting to become an astronaut.
Since I was little, I've always had an affinity for the sky and for space and the stars, and so I set my sights as a very young child on getting here.
It's just a chance to explore and just keep pushing where we can go and what's possible and what people are capable of.
A NASA astronaut is an explorer. They get to go up and live in space and do research so that we can learn more about human spaceflight.
I
Being a NASA astronaut is the most visible part of a much larger team of individuals that are striving to improve humanity.
NASA astronaut to me is an ambassador for the NASA organization as well as its mission.
We're really lucky to be sort of the tip of a huge organization that's all working together to try to achieve some pretty amazing things.
Groundbreaking scientific discovery. That's one of the main goals of the International Space Station program, along with fostering international cooperation, preparing humans for future exploration out beyond Earth orbit, and returning benefits to the people of this planet. This worldwide effort has proven to have one more benefit. It inspires the explorers of the future.
The International Space Station is a state-of-the-art microgravity laboratory that is unlocking discoveries not possible on Earth and helping us push farther into deep space.
Every single day, we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask.
Microgravity turns almost everything we know upside down. Liquids behave completely differently. Fire burns in new ways. Biological systems reveal surprises.
There's a few things that have made me gasp out loud up on board Space Station. Watching heart cells actually beat has been a pretty big one.
We're studying ways to grow food in microgravity.
I got to tell you, these are pretty amazing.
We're learning how human bodies react to life in space, and how to keep crew members safe and strong on long-duration exploration missions.
Deadlifts are awesome on Earth. They're also awesome in zero gravity.
We're testing technologies that will be critical to our return to the Moon and Great Leap to Mars. Our research has contributed to medical and social benefits on our home planet, allowing us to find new ways to combat disease back on Earth and develop technologies to deliver clean water to remote communities in need. The spectacular vantage point of more than 200 miles above our planet supports our monitoring of Earth's climate, natural disasters, and plant life.
I can't begin to describe some of the sights that you get to see. It's just an incredible view of our planet that we have from here.
The growing new space economy, so vital to our continued progress in space, is flourishing in low Earth orbit. We're inspiring future generations from a platform that is one of the largest international collaborations of our time. We're doing science at 17,500 miles per hour. Come along for the ride.
The research goals of the International Space Station include traditional kinds of laboratory science experiments and a number of technology projects that are intended to find ways to make future exploration simpler and more efficient. And that includes a current experiment from NASA's Ames Research Center, which is exploring the use of free-flying robots that could serve as assistants to human astronauts. The effort to use the unique environment of microgravity on the International Space Station to develop technologies to help humans explore space has been underway for more than 20 years now. In this first episode of Tech on Deck, we learn about NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center and its work to test technologies designed to usher in an era of more sustainable, affordable, and resilient spaceflight.
Did you know that if you were born after 2000, during your entire life there has been someone living in space? That's thanks to the International Space Station, which celebrated its 20th anniversary of continuous human habitation in 2020. You've probably heard a lot about the incredible science that happens on board the station, but the outside is actually prime real estate for all kinds of experiments and technology development too.
The International Space Station is a great platform to demonstrate servicing technology because it provides power, data, there's robotics in space.
With Tech on Deck, we'll be talking about some key experiments that have taken place outside in the harsh environment of space, which will help us advance human exploration.
Nexus is NASA's Exploration and In-Space Services Project Division at the Goddard Space Flight Center. The goal of the division is to usher in a new era of more sustainable, affordable, and resilient spaceflight, both near the Earth, around the Moon, and deep into the solar system. Many members of the Nexus team started off with the Hubble telescope servicing missions. We've taken that technology, applied that to robotic servicing.
From robotic refueling missions that will help spacecraft live longer and journey farther to autonomous navigation systems, NASA's Exploration and In-Space Services Division has taken advantage of the wonderful opportunity station offers to test new technologies. As we look to exploring our solar system and beyond, and establishing a sustained human presence in space beyond low Earth orbit, many of these technologies will play a key role.
We use the robots on Space Station to demonstrate the technologies needed to enable satellite servicing in the future. We've also used the robots on Space Station to do some of the more repetitive tasks or the dangerous tasks that astronauts shouldn't be doing, like going outside the space station to try to look for ammonia leaks. Robots are very good at moving fine, delicate positions, moving back and forth, doing those sorts of tasks that would be challenging for humans to do.
In order to live in space, astronauts will first need to reach their far-out destinations like Mars. This will require refueling and replenishment of oxygen supplies, things the robotic refueling missions worked to demonstrate on station. They will also need to be able to construct, maintain, and repair their habitats, as well as adapt to unforeseen circumstances.
Because we're in space and low Earth orbit, we have lighting conditions that are representative of objects in space, and so allows us to launch tools and modules into orbit, put them on the space station, and then use those robotic technologies and all the infrastructure that comes with the space station to mature those technologies in a way that's much, much less expensive than if we try to launch our own satellite and demonstrate those for the first time, not using the space station.
For these endeavors, Nexus's work with astronaut tools, satellite servicing, and on-orbit assembly and manufacturing will do the trick.
We develop the technologies that are needed to advance exploration in ways you can service satellites in the future, build satellites and build structures on orbit, refuel satellites on the way to other planets, repair those satellites much like we do on that side of space station. Both humans and robots are used to maintain habitats in space. We're developing technologies that can be used by NASA and others to make those a reality.
The International Space Station is the perfect testing ground for technologies that will be used to propel humans farther than we've ever gone before. The station is helping us build the necessary foundation to make it possible.
The astronauts and cosmonauts on the International Space Station work on science research in a wide range of disciplines, and the station serves as a platform for instruments that study activity below the station, including colorful bursts of energy above thunderstorms. The instruments that help scientists study these transient luminous events may prove useful to better understanding our climate, our weather, and the behavior of storms.
If you're on the ground during a thunderstorm, you might witness a spectacular show of lightning. But if you're observing that same thunderstorm from the vantage point of the International Space Station, you might see a bolt of energy shooting up from the clouds, and it might be red, or blue, or even green. These particle outbursts are like nothing seen from the ground and may prove useful to predict weather outcomes more precisely, better understand changes to our climate, and increase the safety of planes and ships approaching dangerous storms. They have names that sound like they were taken from a fantasy novel: Blue Jet, Gigantic Jet, Red Sprite, Halos, and Elves. But all belong to a more scientific-sounding family, transient luminous events, or TLEs. Flashes and glows that appear above storms that are results of activity occurring in and below those storms. Dr. Timothy Lang is a lead research aerospace technologist at NASA's Marshall Space Flight Center. He explains how two key observational instruments aboard the orbiting laboratory are helping scientists better understand these colorful bursts of energy. We use the Lightning Imaging Sensor, or LISS, to map lightning in 2 dimensions with global scale coverage. It shows us where the thunderstorms are taking place and how powerful each one is based on the size of its lightning flashes. So it's akin to a macro camera. Another instrument, the Atmosphere Space Interactions Monitor, or ASIM, is operated by the European Space Agency. ASIM gives us very fine detail of a TLE's flash. In essence, it's akin to a micro camera. Torsten Newbert, ASIM principal investigator at Denmark's National Space Institute, adds that ASIM and LISS make observations in different ranges of the color spectrum, allowing for different views of these particle events. So LISS is macro, ASIM is micro, and together they provide a powerful combination for exploring lightning and TLEs. The space station offers an excellent vantage point to scientists studying TLEs. At about 250 miles up, it is much closer to these phenomena than a geosynchronous satellite. Further, the station's orbit allows for coverage of storms worldwide. All this allows LISS and ASIM to produce a unique space-based data set of thunderstorms and their effects, which in turn helps support other observational instruments. LISS, for example, has been used to calibrate instruments and verify data for the geostationary lightning mapper on NASA and NOAA's GOES satellites, and will also support the lightning imager on the European satellite Meteosat 3rd generation. This support helps make data produced by these sensors the highest quality for serving the public. From the space station, LISS can provide lightning data in near real time for the benefit of those on Earth. It can report lightning nearing dry areas of forests prone to wildfires. It's integrated into the NOAA Aviation Weather Center's operations, which provide weather forecasts and warnings to the U.S. and international aviation and maritime communities. And over time, it can map data points to help scientists observe changes to our climate over broad tracts of land and sea. In short, studying lightning and its effects both below and above the clouds can have a big impact on how we view our planet. Doing so from the International Space Station is improving that view in ways that couldn't be accomplished anywhere else. For more electrifying information about the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
Astronauts are public figures and much of their history is well known, but not all of it. So we grilled the astronauts who flew to the International Space Station on NASA's SpaceX Crew 3 mission: Raja Chari, Tom Marshburn, Kayla Barron, and Matthias Maurer, to discover the truth about their favorite foods, guilty pleasures, and what these explorers would do with a free day on the moon.
3, 2, 1.
Star Wars. Stanley Kubrick's 2001: A Space Odyssey.
Probably Life is Beautiful or Amelie.
Master and Commander.
Ooh, depends on the era of my life. I'd probably say Dune, though, overall.
Daniel Burstyn's The Discoverers.
The Perfume.
The Rick Atkinson Army at Dawn series.
Just relaxing.
Playing with my kids.
Backpacking.
Backpacking.
That would be probably peanut butter.
Pizza.
That's a hard one. I like almost all food.
Fall.
Fall.
Fall. French horn.
Acoustic guitar. That's easy.
Guitar, but I have lack of talent. Practice a lot, but failed.
Pesto.
I think on choice, I like pizza Napoli.
Tomato and pepperoni.
I like a spicy Italian sausage.
Swimming. Water polo. Anything in the water.
I'm bad at many of them. Probably kickball with my kids.
Well, it's football, European football, cycling, swimming.
Track.
Coffee.
Tea.
Definitely coffee.
Both.
Dancing.
Singing.
I think I'm really bad in dancing.
Ooh, I have two answers for this. Probably learning Russian, challenging for me, and definitely spacewalk training.
NBL or spacewalk training.
Speaking Russian while in a spacesuit underwater.
Oh, waiting for the mission.
Oh, definitely look at rocks with Jessica Watkins.
I'd go on a buggy ride.
I would be skipping and running and climbing any crater I could find.
Well, first I would like to jump as high as I can to prove that I can jump 6 times as high as on the Earth. And the second thing I would do is I would try to explore a moon cave.
Would be flying.
To pacify the world.
To time travel.
Frappuccinos.
Eating ice cream, way too many.
Cookie cake.
I would say never close a door on yourself. Like, don't self-select out of opportunities. Like, you have to put yourself out there if you want to pursue your dreams.
Keep at it. Stay persistent. Don't worry about it. It's going to be okay.
Just relax and enjoy the moment a bit.
I'd like to do another spacewalk.
I'd love to do a spacewalk.
Doing a spacewalk.
Well, flying to space is the first, doing an EVA is the second, and hopefully walking on the moon is the third.
I won't go into specifics, but it all has to do with using the bathroom.
When you look up at the night sky, you notice that the moon changes shape from night to night. Those different shapes that we see from different times of the month are called the phases of the moon. And in this demonstration video, NASA astronaut Anne McClain and a friend with an Earth-shaped head explain why the phases of the moon occur as they do.
Hi there. My name is Anne McClain, and I'm an astronaut who has lived and worked 250 miles above the Earth's surface on the International Space Station. Today we're going to be turning our eyes toward the moon and learning more about what causes the moon phases. But before we check out the moon phases, let's take a look at where the space station is compared to where we are on Earth and where the moon and the sun are. On Earth, you're only about 250 miles below the station. The moon, however, is located 238,855 miles on average from Earth. You could fit 30 Earths in that distance. When you think about how far away we are from you on the station versus how far away the moon is, the station is only a tiny bit closer to the moon than we are here on Earth. And that's only when the station is in orbit on the same side of Earth as the moon. So, the station is 250 miles away, the moon is 238,855 miles away, and the sun is approximately 92,900,000 miles away. That is quite the distance. Now that you know where you are relative to the station, moon, and the sun, let's talk about the moon phases. Now, when you're looking up at the moon from the Earth, you'll notice that it looks different from day to day. We call these differences the phases of the moon, and they cycle through every 30 days. Let's check out a demonstration of the moon phases here on the ground. We're going to pretend his head is Earth, letting him view the moon as you would from your home. The ball in their hand is going to represent the moon, and the light source is going to be our sun. Keep in mind that while the moon is orbiting Earth, Earth is also rotating on its axis and slowly orbiting the sun. Now, Looking from our outsider perspective, we can see the moon is still whole the entire time it is orbiting around Earth, with the side facing the sun always illuminated and reflecting sunlight. Let's take a look at what he is seeing. As you can see in the photographs from Earth's view, the reflection of sunlight looks quite different from this angle, since we are only able to see parts of the reflected sunlight as the moon moves around Earth. This is what causes our moon phases, as the moon orbits around Earth every 30 days. There are names for each of the phases of the moon's 30-day cycle. When the moon looks completely dark, we're experiencing a new moon. This is the beginning of the 30-day cycle. It will move through a waxing crescent phase until it is a first quarter moon. From here, we will see a waxing gibbous until the moon appears fully illuminated. You might have heard this phase before. This is what we call a full moon. After this phase, the moon will go from a waning gibbous phase into a third quarter moon. After the third quarter moon, it will become a waning crescent until it returns to a new moon. On the space station, we see the same moon phases as we do on the Earth's surface. Since the space station is only 250 miles closer to the moon than we are here on the ground, astronauts on the station have the same perspective you have, but don't have the Earth's atmosphere in their way for photographs. Astronauts currently on the space station actually use the moon's phases to collect research that will help NASA with the Artemis program as we work to go forward to the moon with our astronauts by 2024. So, the next time you're outside, take a glance up at the moon to check out what phase it's in. Are you interested in seeing the space station fly by as well? Ask an adult to help you sign up for Spot the Station at spotthestation.nasa.gov. Thanks for learning with me today. See you next time.
If you want another look at any of the stories we showed you today, go over to YouTube and Facebook at those addresses right there on the screen. You'll find them all there, along with lots of other great features on a whole variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. It's our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan gets educated on the work now underway to build the first few Orion spacecraft, the ones that will fly the first missions of the Artemis program to return Americans to the moon. Go to nasa.gov/podcasts. That's where you'll find this week's episode and all the previous episodes and the full library of all the NASA podcasts, which you'll also find on Apple Podcasts, Google Podcasts, and SoundCloud. And you can get the latest from all over NASA delivered to you every week. Go to nasa.gov/subscribe to sign up for the NASA newsletter.